Yeah, ready when you are. You don't have Microsoft 5 minutes? That's our timing usually.
Is this working? Can you guys hear me? Yes. All right. Welcome. My name is Paul DeDuke. I'm a teaching associate professor with the Herbst program for Engineering, Ethics, and Society. I'm also director of engineering leadership. Thank you all for coming, you guys. This is great. I very much appreciate it. So I'm just going to start with a few remarks and then pass it over to Lucky. For those of you who don't know, tonight's lecture is the first in a new series titled the Moulakis Lectures in Responsible Engineering. Way back in 1988, Thanasi Moulakis became the first director of the Herbst program, then called the Herbst Program of Humanities for Engineers. This lecture series is dedicated to his memory, but also, and I think just as importantly, to his vision for the kind of program that Herbst represents. So I want to start by reading just a little bit from Moulakis' 1994 book, Beyond Utility, which he wrote to address the challenge of bringing liberal learning to STEM. My specific interest is to give you a sense of the kinds of problems that informed Moulakis' approach to educating engineers. I think this is a fitting place to start, not only because Moulakis helps us to sharpen our own sense of purpose, but also because Lucky once told me that Moulakis' book is one of the very few that you kept from college.
It's true.
Yeah. So I'll read now from Beyond Utility. The modern world lives by the products of technology. Technology, in turn, depends on human ingenuity. High technology depends on highly trained ingenuity. Consequently, industrial society has come to depend less on things like physical labor, land, or industrial plants than on the trained and informed minds of people. Education, and higher education in particular, has become, in this instrumental sense, the pivotal institution of the modern world. It is important, therefore, to ask ourselves if it is doing what it ought to do, if only because the ingenious technological processes and products of modern science, or their real and potential byproducts, also threaten to destroy our world. Fears of nuclear and ecological catastrophe naturally focus the mind on the necessary limits of human endeavor. But quite apart from that, no education focused on mere survival or devoted to some blind process of growth would be worthy of the name. And further, industrial society depends on sustained and perpetual material and cognitive growth. If one were to reverse this process, supposing that were possible, half the people in the world would starve, and the other half would be at each other's throats. We cannot predict all the consequences of administrative industrial development. No doubt there is cause for concern, not least ecological concern, just as there is cause for hope. But there is no turning back. We cannot sail straight into the wind. We can only tack as adroitly as we can, but this requires more than the possession of a cumulative body of knowledge made available by specialized experts. It requires, like citizenship, a qualitative capacity of judgment and good sense. It is Moulakis' core contention in Beyond Utility that it is only through liberal learning, the close study of texts asking fundamental human questions, that we can recover the qualitative capacities necessary for responsible citizenship and governance in our technological world. I hope that you can appreciate from my quotes that for Moulakis, the liberal education of engineers was not simply a concern to provide polish or well-roundedness. Moulakis understood that the goods afforded by the study of human things are for us, and for our STEM students especially, a matter made urgent by dint of our circumstances. So with that, by way of orientation, let me introduce tonight's special speaker. Lucky Vidmar currently leads Microsoft's intellectual property litigation team, which is responsible for managing the company's global patent, trademark, copyright, and trade secret docket. Previously, Lucky was a VP and Technology Counsel at Western Union, managing its IP portfolio and key technology vendor relationships. Before that, he was partner in Hogan Lovells IP litigation practice group. Before becoming a lawyer, Lucky worked in the software industry for 10 years, including on systems to improve response to earthquake, tsunami, and volcano disasters. Lucky holds bachelor's and master's degrees in computer science from the University of Colorado at Boulder, and he has a JD from the University of Denver's College of Law. But perhaps most importantly for us, Lucky was a student of Thanasi Moulakis and part of the first generation of HERP students. So please help me welcome Lucky Vidmar.
Thank you, Paul. Thank you very much. I was also a student of Leland Giovanelli. It's nice to see you. So Athanasios Moulakis, right here, known to most of us as Thanasi. He was born in Athens, Greece in 1945. Now, you can go and look up his complete CV online if you want to read it. But let me just say that he has taught at major universities in Europe and the United States before landing right here at this great seat of learning, as he called it, to lead the HERPS program in the late 1980s. He was the intellectual force behind the program, which he led during his ascendancy. How many years, Leland? 11 years. Wow. He later had similar impacts at universities in in Switzerland, in Iraq, and in Afghanistan. He spoke and wrote in English, German, French, Italian, and Greek. But he was also a guy you would want to have a beer with, or a glass of wine, or scotch. He enjoyed life, really, in any language. So I first met him in 1991, but really we became close in 1993, 1994, during what we then called the Senior Herbst Seminar. Later I was his TA and mentee, and I always hoped a friend. I was at the time a recent immigrant from Mediterranean Europe, and I found in him, something familiar. While at the same time, he representing something completely foreign to me, right? I was a kid from a poor family, and he was this refined, well-read polyglot who could quote Plato to you at the drop of a hat. But, we had some things in common. So he and his wife, Gail, lived in a big, beautiful house up near Chautauqua with these breathtaking gardens, and he would often have students over for drinks and food while we talked about great books. No, as with much else these days, that house was torn down. It's no longer there. But the memories of those days remain, and really the seeds of those evenings with Thanasi and my fellow students is what brings me here today. So going back to that time, back in the early 1990s, Thanasi's central belief was that in the critical importance of liberal education for engineers, as Paul said. He explained it all in his book, pictured right here. As Paul also said, this is the only book from my college days that survives in my library, and I actually reread it, cover to cover, getting ready for what I'd like to say to you. So to Thanasi, quote-unquote liberal education meant education that is an end in itself. I mean, it's sort of a classical definition, right? The education that is its own reward. He would often tell me at the end of the spring semester, as he would be jetting off to his house in Florence, he said, I'm going to reread Plato under the fig tree in Florence. And then he would wink, and off he went. And there was no point of him reading Plato. I'm sure he read it all, probably in multiple languages. But, to him, it was the pleasure of it that made it liberal, right? That was all you needed. You didn't need any other reason. It was freeing to do it because you could. And in fact, he titled his book Beyond Utility, right? Liberal Education Beyond Utility. So we're not going to search for utility. So it might sound slightly odd for me today to kick off a lecture bearing his name by maybe slightly disagreeing with that premise today. So now let me be clear. There's nothing wrong with learning about ethics or learning about anything just based on its own reward. Absolutely nothing. But for engineers, in our times, I think learning about ethics and responsibility calls for some more intentionality. The engineering profession cannot be practiced if it's separated from the human context in which it exists. Or, let me be precise, it cannot be practiced ethically and responsibly in that way. And I'm not sure that we can break down this wall between engineering and its human context only by accidental brushes with great books and art. I think to get there, we will need a purposeful and intentional study of those great books and art to learn about humanity, our own humanity, humanity of the users of what we create, the stakeholders of our communities. So today, I think, educating responsible and ethical engineers, which Tanasi would call liberal education, is not optional. It's not incidental to some other noble pursuit. Educating engineers in responsibility and ethics is no less important than teaching them differential equations, for example. If you want to be an effective engineer of today, this is part of the skill set that will differentiate you from what I will call engineers in name only, if you will. These are robots, right, who go through their profession, go through the motions, but they can just as likely be replaced by robots. So knowing this view, knowing Tanasi well, knowing this view of liberal education, I struggled quite a bit with this contradiction as we were establishing this series, and I talked to Paul and Diane about this. But thinking about it some more and getting ready for today, I think actually Tanasi would be okay with this. So let me try to explain. So to guide our discussion today, I want to tell you about Melvin Kransberg here and his 6 laws of technology. So in 1986, our friend Melvin here was a professor at Georgia Tech, and he jotted down what he called some truisms, this is his words, truisms that applied to quote-unquote technology. So this was 1986, mind you. Most people have not heard of Melvin Kransberg. People don't really talk about his laws very much, but I think this is going to be useful as a framing for what I want to talk to you about. So I'm only going to talk to you about 3 of these laws, and 2 of them pretty quickly. Feel free to use your favorite search engine as long as it's Bing, and then you can find out about the rest. So let's look at the first law. So technology, Professor Kransberg says, is neither good nor bad, nor is it neutral. Now, most articles today, if you go read them, they'll say, this is the most important law of technology by Melvin Kransberg. To be fair, most of those articles disagree with one another as to what this law means. And if I'm honest, I'm actually not sure what it means either. I kind of picture Professor Kransberg as sort of a playful sort. I don't know why. So I think he wanted us to read the first part, right? Technology is neither good nor bad. And instinctively be like, yeah, that's right. That's right. We don't do good and bad. We're engineers. The good and bad is for ethicists, and let them worry about, we get the specifications, we build a bridge or whatever, and we're done. But then he throws us a curveball and says, but it's also not neutral. So what is it then? Is it both good and bad at the same time? I think, I think a better reading is that technology is made and technology is used by human beings, and therefore it's subject to both good and bad predilections of human beings. Usually there's probably a trade-off between the good and the bad. Now, what does it mean that it's not neutral? What does that mean? Does it mean that technology takes a side in some argument? And if so, whose side? I don't know. All good questions. So for help in understanding Kransberg's first law, I took a look at what Tim Cook, as a CEO of a software company in Cupertino, you may have heard of. Now, he had this commencement speech at MIT, and he said, technology is capable of doing great things, but it doesn't want to do great things. It doesn't want anything. And I think that is right. I think that's probably the best restatement of Kransberg's first law that I've found. That law, I think, basically says that ascribing value to technology, so good, bad, tool, weapon, whatever, these words have a meaning above and beyond the underlying technology. Somebody else frames that meaning, right? So file all that away for now. We'll get back to that. We'll get back to the first law, and we'll get back to Tim as well. So let me look at the second law for a second. So invention is the mother of necessity. This one's a little more subtle, right? Play on words of the old adage that goes the other way around. But if you stop and think about it, it really is true, right? I think what he's saying here is there's this utopian idea out there that invention just come out fully formed, right? It's all ready to go. It sweeps away the old overnight, right? We talk about killer apps, disruptive innovation, right? But the reality is that the moment of invention is just the beginning, right? It's just the beginning is where the real work begins. Think of the phrase, there's an app for that. You've all heard this, right? We've all said it. Okay, well, when the iPhone came out, the invention, right? It necessitated all of this follow-on invention. All of these apps were not possible before the invention of the iPhone, right? So the invention was the mother of all these necessities that follow on. So, as I said, the moment of invention brings about the need for refinement and further development of those light bulb ideas. And actually, this is where most of your work as engineers will happen, right? Every once in a blue moon, maybe once or twice in your career, you'll have that big invention, but most of the money you'll make is doing the follow-up, right? Doing the refinement, doing the fixing, dealing with what you did not foresee when you first started, right? All of that is good. All of that is human. It's all about facing the consequences, adjusting for them, and it's a need for a million and billion little decisions made by humans to shape the technology that is being developed. So I think Kransberg here really recognizes the reality of deliberate, intentional, incremental change and the value of it. And this, if you think about it, is really how humans operate. And so this brings me to the sixth law, which is where I want to spend the most time on today. And here Kransberg says, tech is a very human activity. Let's think about that for a moment. And maybe let's go back to Tim and see what he may have said about this. So back at MIT, Tim Cook said, as we read before, right? Tech is capable of doing great things, but it doesn't want to do great things. It doesn't want anything. But then he continues. It says, that part takes all of us doing great things, right? That part takes all of us. It takes our values and our commitment to our families and our neighbors and our communities, our love of beauty, and belief that all of our faiths are interconnected, our decency, our kindness. So in this context, when Tim Cook says that technology doesn't want anything, I think what he says is that technology is nothing, quite literally nothing, when viewed in isolation and separate from humans and humanity. Or as Tanasi put it in his book, he said, puppets are not responsible. They deserve neither praise nor blame. Fair enough. So if technology doesn't want anything, and technology by itself is not responsible, where does that leave us? As I mentioned, it's tempting to focus only on the first part of Kransberg's first law, right? Technology is neither good nor bad. This is your guns don't kill people, people kill people argument, right? A lot to love about that argument, right? For one, there's this neat congruence of not assigning human values to inanimate objects, right? You can do this thought experiment of extraterrestrials floating in cosmos and they find an assault weapon, right? Would they think it's good or bad? They wouldn't, right? Without knowing us and our humanity, they wouldn't have any way to assign that value to it. But this, completely ignores the sort of guns don't kill people, people kill people, right? Completely ignores the humanity in which these tools are used. And this is where Kransberg's call against tech neutrality comes in, right? Not only is he saying that technology is not neutral, I think he's loudly calling for us engineers to realize that the technology we create will not be neutral. And if we care for the humanity around us, we should work on technology that is not neutral in a positive way. Now, let's look at some examples, right? So we could, of course, talk about nuclear weapons. We could talk about facial recognition software. But let's talk Pokemon instead. Okay, not sure if you're fans. My wife loves it. I don't play it, but here's what I want to talk about Pokemon about. So it turns out that Pokemon Go doesn't have very many Pokestops in predominantly black neighborhoods. Shown here on the left at this Pokestop Desert, whereas on Nob Hill in San Francisco and probably here in Boulder, there's plenty. You just can't walk outside without stepping on one, right? Now, I think we'd all agree this is bad, right? This is bad Pokemon. Or do we, right? The outcome is bad, but is Pokemon as technology bad? Like, I would like to think that creators of the game did not intend this outcome at all, right? But should they have foreseen that the player base that they were directing this game to would be of certain makeup, demographically, and thus sort of by design exclude minority neighborhoods from coverage of the game? And if they didn't think that, they created technology that is not neutral in a negative way, right? It literally takes sides. It literally takes sides from one side of the tracks to the other. Okay, let's look at another example. Everyone's favorite bugaboo, Facebook or Meta. So a generous version of the story of Facebook is it allowed people from all over the world to connect. You see your high school friends' pictures. The people connected in brand new ways that didn't exist before. True enough. Here's their mission statement. Give people the power to build community and bring the world closer. How would you argue that this is anything but good, right? And look, you're doing it in very non-metaverse ways. You're picking turnips or potatoes or whatever out of actual dirt, right? But we all know the bad, right? We all know the bad of Facebook. It's created these echo chambers for like-minded people, and this has led to people stop listening to each other, stop talking to each other, thus becoming more strident and partisan. And so the reality is that Facebook, the technology Facebook, was not designed to be neutral at all. It isn't neutral. It is designed to create the outrage, fuel these divisions, amplify fake news, all with the aim of selling people more advertising. That's its design. So it's not an unforeseen bug in the Facebook tech. It's the core tenet of its design, right? And so we could go on and on about all of this. You probably all heard the phrase, if all you have a hammer, everything looks like a nail. I mean, it's funny, but it's very true. I think we as engineers should keep this very much top of mind. We as lawyers too, by the way. And this is because, a new engineering tool or a new technology, they're not like a tree, let's say, right? A tree grows and the tree is also neither good nor bad, just like technology, as Kransberg said, right? So the tree could grow tall and leafy and provide shade for your backyard, help with global warming, but it could also topple over and kill you in your bedroom, right? The difference between the tree and Facebook is that technology, right? Technology is something we create intentionally. We humans willingly and consciously create it, bring it into the world. Before it's ever a thing, we engineers supposedly think long and hard about the designs. We make choices, right? This is not accidental. None of it is accidental. It's actually usually very purposeful. It's built to fit certain need. So if we, engineers, insist that technology is neutral, then we free ourselves as the creators of any blame on how those technologies impact the humanity and how they change the world. Now, if we engineers wash ourselves of the blame for our creations, then we necessarily also disown any praise for those inventions. It stands to reason. And if our creations deserve neither praise nor blame, then what point is there to them? So in 1986, Robert Welkel wrote this in the IEEE Technology magazine. It's a little long, but I think it's worth reading. So he says, speaking about this concept, he said, this moral neutrality is based upon viewing technology purely as a means that is providing tools for society to use. The ends, so the actual usage of technology, are beyond and outside of the realm of engineering. So this position also assumes that available means have no causal influence on the ends chosen. So if technology truly is only a means, then engineering is a second-class profession, since we are the mere pawns of the real power brokers. We buy our innocence at a tremendous cost. To be innocent, we must be powerless. Now think about that for a second. So if you know a little bit of your New Testament, this could remind you of Pontius Pilate, right, washing his hands of any credit or guilt for fairly consequential decision he made. And history has not treated him kindly for this. And I would tell you, history is not going to treat any of us kindly who take this approach, right? This is make-believe, right? We engineers are not powerless. You can pretend to be, but you're not, right? If we're designing a proverbial hammer, we have a responsibility to think about what sort of nails this tool may be banging on by the humans to whom we give it. This is the minimum. If we care to look and think, the actual ethics of the tool is not accidental or dependent on how people use it. So be on the lookout for that. Be on the lookout for technology that is not neutral in a negative way. And strive to create technology that is not neutral in a positive way. Because the humanity demands this of us at a minimum. So how do we get there? So let me try a three-step process. So step one in becoming a responsible engineer is understanding this key point, that technology or engineering is a very human activity. The human being is at the center of it all. And our responsibility is to the human being and not to the thing we create, right? It's not a bridge we're building, it's a way for Jane to go to school. It's not artificial intelligence, it's a cure for cancer for someone, for a human being. Step two, Thanasi would tell you, is to start honing our human language. Right? I hope you all agree that the central attribute of a human is the ability to converse and communicate highly abstract concepts. And I don't mean here the mere information sharing where I direct some data at you about weather today, let's say. Machines can do that very, very well. What I mean by human conversations is those that engage the humanity of the speaker and the listener. And Thanasi put this so beautiful in his book, actually. So he writes about a doctor, a lawyer, and an engineer. It's not a joke where they go in a bar. But anyway, the doctor, lawyer, and an engineer, he says, can have a conversation about a Shakespeare play, about a football game, about a beautiful car. They can have a conversation. But they can only inform each other about vaccines, torts, and fluid mechanics. He went on to say, when people have no more to share than their respective expertise, they no longer meet as humans. They meet like members of a committee. He didn't mean that as a positive, by the way. So we all fall into this trap, right? The beautiful, useful, and advanced products that you are all designing are only accessible to those who are conversant with the internal notations, internal language of that field. But they're really incommunicable to people in normal human language. And Thanasi actually called it unspeakable, inaccessible, foreign. In any way opposite of acknowledging and honoring the humanity of the users on whom these technologies are intended to be operating. So this is not where we want to be, right? We don't want to engage in engineering that way because that does not make it a very human activity. So for each of your disciplines, I would suggest to you, develop a way to talk about it in human terms. Now, this is not just about not using jargon, well, although that is part of it, right? It's about framing how you talk about what you do from the human perspective, right? Questions like, what should you, the human, worry about what I'm doing? What is the range of possible outcomes? What does the success look like of this project for this human or that human? It will be different for each of you, but try to find that way of talking about it that humanizes the subjects of your work. Now, the flip side of this language barrier is, let's call it hubris. Let's call it excessive reliance on science, blind confidence in capacity of science to deliver results. As Thanasi put it again in his book, here's what he wrote. He said, when science is seen to be flawed, as at some point it must, the entire edifice is called into question, opening doors to every conceivable irrationalist. Now remember, engineering is a human endeavor, human activity. As such, it is flawed. It is flawed. Engineering as a human endeavor always operates in some degree of uncertainty. Just expect that. Don't downplay that when you talk about what you're doing. Expect it, normalize it, communicate it. Okay, step 3 is, drink of water. Step 3 is finding your own place in this human endeavor. Right? What does it mean to be a responsible engineer? What is responsibility in this context? Harvey Mansfield actually said this right here at the College of Engineering some 30 years ago. He said, a responsible person acts on behalf of the people by doing what they cannot do for themselves. So put another way, responsibility is doing what the people would want if they could do it, or if they knew how to do it, okay? So the takeaway here is that responsible engineering is not some finger-wagging set of prohibitions, right? You will not do this, you will not do that. At its core, it's actually the other way around, right? It's a call to action by all of us on behalf of the human beings who interact with our creations. Okay, so let's take a little breath here. We've talked about a lot of fairly theoretical things so far. So you may be thinking, as an engineer, I'll have clients and they'll tell me what they want. I just build it, right? Or my boss will give me the specs and I'll write the code. And customer is always right, right? Right? No, wrong. So customers won't always be right. Let's just be very clear. The customers won't always be clear. They won't always be consistent. Customers might be confused. They might not realize the impacts of what they're asking for, right? Your management, believe you me, is the same. Clear, confused, very often. But all kidding aside, your management may not know how to do things responsibly, how to create something that's neutral, not neutral in a positive way, right? They may not be realized that they're asking you to create something that is not neutral in a bad way. They may not know. They may not know that there's a way to do the task responsibly. So it is our responsibility, each of us, our engineers' responsibility to fulfill customers' and management's needs in a responsible way. It's on you. You're not a robot, you're a human. The customer is human, your boss is human. You don't outsource your humanity to someone else, I think. And in the same way you don't outsource your responsibility. It's on you. Okay, another danger of our time to be on the lookout for is relativism. You can call it both-sidism. Thanasi highlighted this risk actually in his book back Beyond Utility. So he wrote this. He said, quote, "One opinion is not as good as another, nor is it validated simply by being held. The ostensibly easygoing, I'm okay, you're okay, acceptance of otherness is really a form of self-indulgent indifference toward that otherness, which neither tolerated nor embraced." Sorry, let me read this again. So it's a form of self-indulgent indifference toward that otherness, which is neither tolerated nor embraced, but shrugged off. So he didn't stop there. For good measure, he called this both-sidism. He called it anti-intellectual and moral laziness. I think he felt pretty strongly about it. I happen to agree with that, with him, right? We don't need to get into all the implications of this to our society today. You could say a lot, but for our purposes, I think what Thanasi means is that to see humanity in another, you actually have to see it, right? You can't just brush past it. And sometimes to see the humanity in others, you have to disagree with that person. And you have to tell them that you disagree, right? So it's not that ethical and responsible engineer will always reach one and only one outcome. There's often going to be different ways to get at a positive outcome. But the point is that not every approach and not every outcome is equivalent. So here, I wanted to very briefly touch on the concept of psychological safety. So this was popularized by Amy Edmondson, a professor at Harvard. You could have an entire lecture on this topic, an entire day on this topic, and may I suggest maybe you should try to get Amy out here to talk about this, because I think this subject is really key for what we're talking about here. So her entire concept is that a psychologically safe environment is one where interpersonal risk-taking is safe or feels safe. Okay, so she's talking about organizations and how we operate, and she's talking about the need for speaking up with ideas, suggestions, questions, concerns, or pointing out mistakes. That doing that is not just accepted, but it's encouraged, it's expected of our teams. So what's holding us back from being a fearless organization or a psychologically safe organization? Well, it's you don't want to look ignorant, right? You don't want to look incompetent. You don't want to be intrusive, negative, right? You don't want to be the complainer. And what do all these things have in common? Well, they're quintessentially human fears, right? You walk into a meeting and you disagree with something, and you know strongly that whatever's happening is wrong, but you say nothing for any of these reasons, right? Because we have fear of speaking truth to power, or you don't want to stick out from the homogeneous opinion or whatever, however wrong it is, right? So the tools of psychological safety go at the very heart of this human experience, right? And I think that can be very useful to you as an engineer. Now, we spend a lot of time on this at Microsoft, and I suspect other places do as well. I know workplaces that don't, that actually operate exactly the opposite. And I would suggest to you, if you want to be a responsible and ethical engineer, to never work in a place where open dialogue is not welcome and encouraged. Try to figure out if this place is psychologically safe. Now, how do you do that? I would say ask some very pointed questions during interviews. For example, tell me a recent time somebody disagreed with your design choice. How did you handle it? What are one or two things that you recently did to ensure that diverse voices on your team are heard? Specific things. How does it make you feel if your boss asks you to implement a design you think is bad or unsafe or whatever? Right? Ask those questions and listen to how people answer, because I think you'll be able to suss out if people are running around scared or quiet or just sort of ho-hum, shrug the shoulders, or if, you know, or if the environment is one, as Amy says, where speaking up, noting potential errors, giving suggestions is not just encouraged, but expected, because that is human. So you'll get the answers, ask the questions, get the answers, and act accordingly. All right. Let me start to close a little bit here and talk about how we get to become more human as engineers. So can this humanity be taught, you might ask yourself. So on this point, Thanasi was an optimist about 30 years ago. As he put it, quote, if the ethical sense of good taste can be corrupted, as I think we all believe they can, then it stands to reason that they can also be nurtured. He was a practical man. That makes sense. So there's not, of course, a recipe book for this. There's not a body of responsible engineering and ethics to be acquired and check the box. Maybe that's where this is different from differential equations. But as Thanasi put it, you know, somebody can teach you which fork to use with the salad course, but to become a polite person, you have to internalize that yourself. And the same goes for ethical and responsible engineering, I think. Great books and art and music and beauty and conversation should all be a part of this education, of course, but it will achieve its end goal when you all internalize the importance of the human in yourself and in what you do as an engineer. So let me just come full circle, and this is where I don't think that Thanasi would object to any of this, actually. The 30 years he noted in his book, I think actually it was pretty early on in the book, he said, quote, the successful engineer is the one who is no longer an engineer. I'm like, what? So, you know, then he goes on to say, you know, talks about engineers who become CEOs or, God forbid, lawyers or things like that. And, you know, and he says, well, in order for this engineer to become a CEO, they had to develop a set of human skills, right, beyond the technical skills that they already had. And, of course, those skills would make that engineer successful, you know, but perhaps at the cost of no longer being considered, quote, unquote, engineer. So I thought about this quite a bit. So for that paradox to actually be a paradox, the definition of engineer must expressly exclude that engineer's humanity, right? Thanasi said so. Page 1 of his book, he says, quote, engineers are bright and equipped to do great things, but don't understand human condition or even their own humanity. Now, mind you, he was talking about engineers of the early 1990s, not about y'all. I know that. And that, you know, that narrow definition of kind of humanless engineers no longer holds today. It's not, this is no longer optional. It does not describe a complete engineer. It does not describe an effective engineer of today. So my hope really is that this lecture series will just tackle this very topic from all sides. I can't wait to see where it goes. I hope that it raises awareness that engineering is a very human activity and that it helps all engineering students at CU and really everywhere train their human side. So I urge you to nurture your humanity. Don't suppress it, nurture it. Seek beauty, wisdom, pleasure, pain. Get raindrops on your face and laugh, care, and demand care. And practice speaking up. It will help later when stakes are higher. And as Thanasi would tell you, read, write, and have conversations as a human, not as a member of a committee. Thank you.
So we're going to do some Q&A. I'll just walk around. Raise your hands. You could project, but we got a mic.
Thank you so much, Lucky. That was really great and prompts lots of thoughts. And it occurs to me you are in a unique position to talk about a particularly prevalent phenomenon in America, and that is whistleblowers. We've had to develop a legal structure to protect people who don't feel that within their organizations they can object, they can raise questions. Is this just the media suggesting to us that it's more frequent, or is it in fact more frequent, and why?
I probably should have said this at the very beginning. I work at Microsoft, but nothing I say here has anything to do with them. So don't ascribe anything I say to my company, because we've spent a lot of time on this issue. I think it's more frequent. I think it's real. I think it's more frequent because the decisions the industry is making some pretty massive decisions that are negatively impacting the world more than they used to. And so I would say it's more frequent, but honestly, it's not frequent enough, right? It's for every Frances Haugen, there's probably 100 people who struggle with this, whether to do it and whether it's worth it, right? Because and they choose not to. And I'm not sure you could blame them, right? And this goes back to these, the organizations that are not psychologically safe, the places where it's not good to speak up, right? The places where pointing out a mistake in design or something, would get you, probably doesn't get you fired, but it gets you put on a shelf somewhere where you're not really doing anything fun. So yeah, I mean, I think it's a sign of the technologies raising impact and encroachment into all sorts of human life, but I actually don't think it's frequent enough.
Further questions?
It strikes me that it's difficult to think.
Connor, hang on. Yeah, I want to wait because this is being recorded. So
It strikes me that it's difficult to think through the consequences of introducing lots of technologies. I mean, if something even in pure science comes back 50 years later to have some sort of totally transformative effect on the world, yeah. I mean, how can you even hope to think through consequences of certain technologies?
Yes, but that doesn't excuse you from thinking at all, right? This is the argument people say. Well, it's impossible to know, so let's so let's just release it. I don't think that's doing the humanity any good, right? I think there are things that are foreseeable. There are things that could be foreseeable if people thought about it. Like, of course, there's always going to be some. There may be some things that hasn't even been invented yet, right? That makes this other invention into a dangerous tool, of course. But in terms of what we can foresee and can think about, we need to, right? The fact that, as I said, technology is a very human activity, and so it always lives in uncertainty. It lives in some level of uncertainty, right? So we have to accept that uncertainty. So the one thing, to your point, is you have to say that, right? You have to say we don't know. We don't know how this is going to work beyond this use case, right? We don't know the impact this is going to have on this stuff over here, right? It's actually, in this sense, the engineer's job is not that different from what I do as a lawyer, right? All we do is assess risks and try to mitigate as many of them as we can. This is it. Right? That's basically the job, right? I try to envision all of the risks that I can think of. I write them down, and then I say, okay, I can mitigate these top 6, but these bottom 3, there's no mitigation, right? Those are risks out there. And then you have to say that out loud so everybody knows, right? And I think it's not about guaranteeing that what you create will never misfire or not work right or not hurt someone. I think that standard is way too high, right? The standard of being human as an engineer, is being honest, being ethical about it, being open about it.
Thanks. So you said education is its own reward, and that like Moulakis got pleasure from it. Do you know how he got to that point? Because I don't really like learning.
Let me think about that. Let me think about how I can be helpful to you. Well, I think he got there by a lifetime of curiosity, right? It's not learning. What you don't like learning. You said that's interesting to me. Are you a curious person?
Yeah, I'd say so.
Yeah.
I don't know. Engineering's all right, I guess.
Yeah, I mean, hey, I'm not an engineer anymore, so what do I care? But you're curious. You're curious about something, right? It doesn't have to be engineering.
Just having curiosity makes you have pleasure, then.
I think so. Yeah, I think if you're curious about anything, right? I don't know, sports cars, whatever.
I'm curious about like how to get more fit, but I don't want to like go to the gym.
Okay, so how do you satisfy your curiosity?
What?
How do you satisfy your curiosity about getting more fit?
I don't know. I watch a video about it.
Right.
And then don't do it.
That's fine. That's fine. But you watch the video, right?
Yeah.
Okay, so.
You say that, that's enough.
Yeah.
Right.
Yeah. Yeah, you did it for its own utility, right?
All right.
Is that good? Is that?
That's good.
It makes you feel better today, I think.
Yeah, I guess.
Yeah.
So what you said about Melvin and his first law of technology with it's not good or bad or neutral, at least in my ethics class, what we've discussed is this principle of technological multivalence, or the idea that every technology has an impact to some degree, and those impacts can be good or bad, or most likely a mixture of both. The question I guess I'm trying to aim at is, to what extent can you look at like the applications of engineering in something like the defense industry, where, objectively your outcomes are mostly bad compared to mostly good? And how do you apply ethics in fields where the things that you're designing aren't always going to be morally correct? Is there a way to balance that, do you think?
Yes, I think there is, and you would have to work that out yourself, right? That's the challenge for us all. Whether you go to work for Facebook or for Northrop Grumman, right? You would have to have to work out that moral calculus for yourself, because, I mean, I would say whether working at Facebook or Northrop Grumman, I think that's different than, say, I don't know, working for a cigarette company, right? I mean, it's not. I at least don't take the view that Facebook and Northrop Grumman are universally bad, right? I mean, these are endeavors that one could argue have some positives, right? They could be made not neutral in a positive way, right? But so you have to work that out for yourself about how are you going to be a human being in that environment, right? When when you're, well, and for working in any company, right? When you get asked to do something illegal, let's say. Let's not even say immoral. Let's say when your manager asks you to do something illegal, what's going to be your approach, right? And I think it's not too soon to start thinking about that now. And this is where this education of you as a human engineer, it's not too early to start thinking about that, because you want to be ready at that point. Because if you wait until that moment, he's going to be like, oh shit, like, what do I do now, right? It's too late. So this is what I think all of this education in humanity and in responsibility and in ethics, the sooner you do it, the sooner you start internalizing these things, it's not like the answer is going to be clear, right? But you're going to have the tools, you're going to have the approach. How am I going to approach this moment, right? How am I going to approach the moment when I get a job offer from a vaping company, right? As a mechanical engineer, as my brother-in-law actually just did. I'm not kidding you, right? Right? I mean, it's like, do I really want to do this? I have a 6-year-old and a 4-year-old. I mean, he didn't take the job, but it's none of this I fear is satisfying in terms of giving you answers that you can write down and then go cross-check. But hopefully it gives you the context for the sort of moral decisions that await you, and hopefully for you all to get armed to face it.
This is great. Thank you so much. I teach in the HERPS program, and so we spend a lot of time thinking through us as individuals existing in systems of government and companies and corporate structures and all this. You sort of reach a point, especially I spend half my class on climate change, where you feel really powerless, right? Like, what can I do as one person, as one engineer in the world, and make a difference that is positive? And I was could you offer us maybe some advice, as an individual? Like, how do you make a difference?
Well, you as one person is really difficult. It's really difficult to make a case that any one of us as one person can do very much, right? But if we all decide to collectively, all of us, to start making decisions in a different context, right, in this human context, then I think you do make a difference, right? I will tell you, in my previous job, we at Western Union, we were designing some new tools, and it was going to be kind of just same old, right? Spec, write it, whatever, collect all the user data, use it for marketing. Don't tell them. And a couple of people spoke up and said, well, why don't we, this is not right? We should not only tell the users that we're going to use their data in this way, but actually we're rewriting this whole thing. So if we're already rewriting it, why don't we rewrite it with privacy by default, so that actually out of the box this tool doesn't collect any data? And that's what happened. And it's just started out of a conversation around the table with somebody challenging the orthodoxy, right? Now, is that going to is that going to move the needle on privacy in America? No, right? But if there's enough of those conversations happening in enough places, and also I think if we as engineers hold each other accountable, right, disagree with opinions that are not as valid as others, I think that will help as well. And if we speak up, if we blow the whistle when we see stuff.
I guess my question has to do with your advice to not take jobs that don't have open discourse. And so my question is, if you reject that job, there's always going to be someone else who will accept it. Mm-hmm. So why is it a better outcome to have them in that position than you, if you could possibly make a change within the company?
I don't know that you'll be able to make the change within the company. I think that's the sad truth, right? The places that don't want to hear things like, this space shuttle will blow up if we launch it on this day, right? If you remember the space shuttle blowing up, right? There were people who were like saying, hey, don't do it. These O-rings are going to fail and the thing's going to blow up. Nobody listened to them, right? The place like that is not going to change because you're there. I'm sorry to say. I'm really sorry to say. I'd say take your talents, because all of you here, CU engineering grads, and if you're in Herbst, certainly you're getting that education. You're all going to be very sought after, especially if you build in this human and ethical and responsible component on your engineering degrees, because employers, the employers you want to work for are looking for that skill right out of school, right? They're not wanting to wait for you to be a 10-year engineer to have developed this. They want it right now, right? You're going to be working on products day one, and they want you to have that judgment. So if you smell an inkling that the place you're applying for is not that, I mean, again, it's not an easy choice, right? It's a job, it's money, it's student loans, it's all that, and I get that. But I would think long and hard.
I'm the photographer, but I have a question. So I guess I'm curious. I see so much hero worship in the mainstream media of people like Elon Musk and Jeff Bezos and these brilliant minds. And I mean, it seems like they're businessmen that just use the talents of engineers that are better than them to, I don't know. I guess, what do we do when we're confronted with these narratives of success being based on this kind of interpersonal violence? Sorry if that's a tricky one.
Have you had a chance to read any articles about these text messages that came out from Elon Musk around the Twitter acquisition? Not yet. It's fine. So I mean, it's just mind-boggling, right? What's mind-boggling is how dumb these people are. Dumb. I mean, and I mean, it's not shocking to me, right? I've been in corporate America for a while. And so you see, what you actually see when you get inside these companies is how ad hoc all of this is. You may think, oh my God, these Tim Cook, Satya Nadella at Microsoft, all of them, they're just so smart. They've probably thought through everything. They've game planned every 10 steps ahead of every decision, and that's how they arrived at whatever they're going to do. No, no. It's people who are very often, they get promoted to the level of their incompetence, and that's where they make decisions based on emotion, based on whim, based on personal violence, as you said. I mean, it's so don't be in awe of these people. Don't be in awe of these people. I mean, they're successful, they're rich, whatever, but they're probably, the quality of their humanity is not on display. So have your own. Have your own. It's probably going to be richer and better than theirs.
Oh, I'll be right there.
No, it's on.
All right, so you pointed out that early engineers may have put out humanless technology, and in this age, I believe that technology has transformed my generation's humanity. So I wonder if my generation's humanity is different from your generation's. And if you agree or disagree with this, if my generation starts introducing humanity into technology, where do you think society will go? Like, do you think it'll go for the better or worse, or that where my generation is biased towards unhuman technology?
Oh, I don't think that. Do you think that?
I believe that my humanity may be different from yours.
Yeah, well, I hope so. I mean, but in better ways. I actually have no doubt that your humanity is different and should be, right? I mean, it's not completely different, right? We recognize each other as humans, right? We could have a nice conversation probably, but of course it's different, and it should be different.
Do you think that, but because we were impacted, or like we grew up with this humanless technology, that we may be biased like towards continuing creating that?
Well, I think you may accept it, right? But I don't. That's an interesting way you put that. I wouldn't define your humanity by just blindly accepting what this technology that was created ostensibly for you, right, not by you. The way that is inhumane, that somehow defines you and your generation, right? It's not your fault, right? It's my generation that designed this crap the way it was, right? So I think what I would recognize as your humanity is not this impersonal, always on tech. I mean, that's part of your experience, but I think your humanity is a lot richer. I mean, you are, of course, your humanity is so much better at being adept to this technology than we are, right? So you probably see it easier. You can see through the BS quicker than we can sometimes. But I wouldn't. I'll have to think about that. I would not define your humanity by the tech that's been operating on you, kind of unfettered for the last 10 years, let's say. I wouldn't.
Hi, thanks. So I have a question, which is, can you speak to the importance of friendship in all of this? Because you've used the words internalize, and for a minute there, I thought you were talking about external as well. The being willing to speak up in meetings and stuff. Can you speak to friendship as being somehow a kind of training ground for that? Because the 4 years of college, then and especially one course in herps, what happens after that?
Yeah, I mean, look, close. So my wife and I recently moved from Denver to Seattle for me to take this job, and it's exciting. You wouldn't think that a person at 50 years old can go do something brand new and different, right? Oh, this is great. And then you get there and you realize, all my friends are in Denver, and my wife said something really interesting. She said, you can always make new friends, but you can't make old friends. And that, I think, is so true. And my life has been incredibly blessed by having a whole bunch of old friends from college. Some from herps, some not, some are here. And I think that gives you that. That gives you that psychologically safe space outside of work, right? Where you can try things out. You can try ways to disagree. You can try ways to persuade. You can try ways to empathize, or all of those things are kind of done in a space that is by definition psychologically safe. And I think. I know my life has been enriched by having that, and so I would say, get that, right? Get that in your career. It'll be useful when that boss asks you to do something illegal. If you have kind of your own board of directors that you can call and toss ideas around, it will be extremely, extremely helpful to have.
Anybody else? No?
One more right here.
You were saying earlier in response to another question, don't look up to these people, don't be in awe of them. Who is it that you look up to in awe?
In all seriousness, my wife and I wanted to start this lecture series, and the question came back, so do you want to call it Lucky Vidmar and Aubrey Ardema series or Aubrey Ardema and Lucky Vidmar series? I'm like, no, I want to call it Moulakis series. So I look up to Thanasi a lot. It's not that you shouldn't look up to these titans of industry, right? I mean, they're extremely successful, but look up to them for attributes that are, they're human, and their drive, their ambition, their perseverance, which Elon Musk has in spades. There's nothing wrong with that, right? But don't think that they're smart just because of that, or that every decision is thought out and brilliant, because often it's not.
I think this will be our last question. Jason, go ahead. Last word, Jason.
All right. So I'd like to question you about humanity. So what would you view humanity as? Do you view it more as humanity as a physical stance, or would you view it more as of the mind?
I would the latter. Humanity. I would say humanity, not just the mind, but the heart, the emotion, your fears and concerns. So it's not just intellectual, right? It's actually very often not conscious, right? It's very often unconscious. The impacts that technologies have on on humans and on societies, they often touch you. Like Facebook is designed for you not to notice what's going on, right? So I would think, when I say humanity, I think more of the sort of inner emotional human self that you bring. The bit of it that that makes your stomach tingle when somebody suggests that you should do something wrong, and you're like, that's the bit.
Guys, let's give Lucky Vidmar a round of applause. Thank you very much.